So here are some different equations. We have the general form, vertical lines, horizontal lines, slope-intercept form, point-slope form, and again, if you use the what I call the algebra 2 one, where the y1's on the other side, fine. This particular problem is asking us to come up with another equation of a line. So it says it's supposed to pass through a point for -2. So I already know the solution point. And it says it's supposed to be parallel to this other line. So you have to picture in your head or coordinate plane. There's a dot here, there's a line on it, and you're supposed to draw a line through the point parallel to that one. So what do parallel slopes mean?
Same slope.
Same slope. So let's calculate the slope here. I would do -4y equals 12 minus 6x. All I'm going to do is send the 6x to the other side. A lot of you can do that in your head, but it goes over as a negative. Now when you divide everything by -4, you end up with an equation that looks like this. -6 divided by -4 is really going to be +3/2 x, right? Now in the exam, if you forget all that, what could you do? Make an xy table, get 2 points, calculate the slope, and write that down. You could do it that way. Slope is 3/2, 0.2. So we're going to use this slope. That's Yep, that's given. Now, when I bring it over here, I'm going to go y minus -2. I'm bringing the solution point. Bring that solution point into this problem. So the -2 gets subtracted off from y. You guys said parallel lines have the same slope, so I'm going to use the parallel slope, the same slope, and we say x minus 4. So y minus y, slope, x minus x, point slope one. Now we want to clean it up. So this is y plus 2, 3/2 x minus, I do fractions mentally. You guys can do whatever you want. If you want to go to your calculator and type in 3/2 times -4, go ahead. But 3 times -4 is -12, divided by 2 is -6, right? I mean, now we have this -2 sitting here, so we're going to subtract 2 on both sides of the equation, and I have a y equals 3/2 x minus 8. That's not our final answer though.
Darn it.
In the problem they say change to the general form or change to a standard form. So we're just going to practice doing that. So that means
We got the +8 and -y.
that means we want to put it in that form. Remember the nice form. So somebody could walk up to it and go 0 here, 0 there, get intercepts, get the graph. That's general form. The rules for general form. A, B, C. No fractions. No decimals. You can't have, if you can't avoid it, get rid of any fractions or decimals in the problem. We want x, well I should do ax and by on the left, and a should be positive. A should be positive. That doesn't say anything about B or C being positive or negative, okay? Only A should be positive. In other words, we don't want a negative sign hanging out in front. I'm going to bring this equation over here. It is y equals 3/2 x minus 8. Do I have all quote-unquote nice numbers?
No.
How can I make them all nice?
Times them by a factor of something.
We can multiply everything by 2. 2. 2. 2. So I'm just putting parentheses to indicate I'm multiplying by 2. Most of you probably can do that mentally, but this is 2y. When you multiply by 2 at the same time, you're dividing by 2. That's the Chunga property. 3x minus 16. Chunga. Latin for cancel out.
Really?
The 2's cancel out. Latin.
We should minus 3x.
So remember, x and y are supposed to be on the left. So I'm going to subtract the 3x.
Don't we not want a negative?
Well, that's when we're gonna do times by -1.
So we're really, really close.
Times
But-
by,
But to make sure that that's a positive, we're going to, now many of you may say multiply by -1. You could divide by -1 or simply switch all the signs, right? Everything switches. So if this is negative, it switches to a positive. If that's positive, it switches to a negative, and that's negative, so it switches to a positive.
That works.
So this is slope intercept, and this is general or standard for a linear. They're all equations of lines. The only reason I took it to here is because they're telling me to. Otherwise, I could have stopped here. Now we're dealing with perpendicular. There's some stuff over there.
Don't you just reciprocate this? That's only if it's negative.
That's 2. I would study this.
Slopes are reciprocal slopes if they are negative. What did I just say? Perpendicular. I think I said.
That's also.
Slopes are perpendicular if they are negative reciprocals of each other. In other words, like fractions are flipped and one's positive, one's negative. What we're telling you there is that it's 1 over 1/2. A lot of times what people do is say if m1 times m2 equals -1, then the two lines are perpendicular. So notice that this is the same equation we had before, which was 12 minus 6x all over 4. What was my slope?
This is minus.
It was 3/2, right?
Yeah.
Sorry, -4. Yep. So the slope turned out to be 3/2 on the last problem, and it turned out to be 3/2 here. So what's the perpendicular slope? Let's just call it m2. What's the second slope then when you do perpendicular? -2/3. So one always has to be positive, one always has to be negative, and you flip it top and bottom. So what I want you to do right now is see if you can plug this slope into point slope form with that solution point. I want you to come up with the slope intercept form. Get to y equals mx plus b. So I want you to check that. And then I want you to take it over to the general form or standard form for a linear. And we'll check that. I'll move around if you have questions, but we're almost done there.
hey, I got a general form.
So, this was our slope, given slope. So we're using the perpendicular slope right there. Now, this causes fractions to happen because of the 2/3. So if some of you aren't comfortable doing fractions in your head, certainly feel free to use your calculator, but -2/3 times -4 gives me positive 8/3. So at this step, all I have to do is bring the -2 over. And what I'm doing right here is showing you -2 and -6/3 are the same thing. That allows me to say 8/3 minus 6/3. So this would be a nice slope intercept. Now, even though there are two fractions in here, there's only one denominator. So my first step is I can multiply everything by 3. And I get 3 times y is 3y. negative 2/3 x times 3 is negative 2x, and 2/3 times 3 is 2.
There we go.
Then, when I bring the x to this side, it comes over as positive, and that's a nice general form or standard form.
There we go. Didn't even say